So sticking some numbers in a formula to start with. Blah, blah, blah. Calculate yy. So part A, I'll just do that here. SYY. Formula is given in the formula sheet, so use it. Sigma y squared. Make sure you pay attention to where all these squareds are. Sigma y squared over n. All of these, sigma y squared, sigma y, and n, given in the question. So it really was a case of plugging some numbers in a formula. Now I certainly think that is easier than trying to get 2 marks in an C4 exam. So just be careful when you stick that in your calculator. You should be coming up with 218. Okay, part B. PMCC. You know that's called R in the formula book. And that's again xy over the square root xx times syy. You've got all of these numbers again. So you've got xx or xy, and you just worked out yy. So minus 710 over the square root of 2587.5 times, which one are we looking at? Minus 7, the 218 that you just got. Figure all of that out, stick it in your calculator into 3 significant figures, 0.945. Interpret this. Interpret. You can't just state that it's a strong negative correlation. You could do. Might be a good place to start your sentence. Strong negative correlation will not get you the mark. That is not good enough. What this means is that as age increases, that's what we're talking about, age increases, blood volume, well, it's negative correlation, must be decreasing. Decreases. Okay, you have to put it in context. As age increases, blood volume decreases. A researcher believes that a linear regression model might be a good idea. Yes or no? Do you agree? Yes, good idea. That's not enough though, you need to put a reason. Yes, it's a good idea. Minus 0.95 is close to minus 1, suggesting a strong linear relationship. Okay, that's what PMCC checks. Remember, it checks to see if it's a linear relationship, and either positive or negative depending on the coefficient. So yep, it's a good idea. Find the equation of the regression line. It's even telling you what form. Nicely, it's still in y's and x's. Remember, some questions they might change it just to catch you out, see if you can change the formulas and everything, but you're given your definitions or your equations for A and B. B you need to work out first, because you need it for A. Again, you've got all these numbers. You've already worked them out, or you've got them in the formula, so you've just got to plug them in. And keeping everything nice and accurate. 7.4 A, a bit more complicated, the average of y minus b times the average of x. You've got all of these. I've used the wrong symbol for average, never mind. Let's get rid of that. So, don't know the average of y, can quickly work it out. 560 over 8, the average of, well, minus the average of x times this 0.274, minus 0.274, don't miss that out. And that one is 370 over 8. Again, a bit of work on your calculator should give you that 82.69. Write your regression line then, everything to 3 significant figures. Okay, last bit on this question. 40 is your x value. Stick it in your equation. Just write down that you're doing that in case everything else goes peaked on. Got plenty of time. Remember, it's S1. It's not going to be that bad. 71.1 millilitres. And then the last bit says, is this a good idea? Is this reliable? Yes. Why? Because we are interpolating. Remember, we are within the data. 40 is within the data range. The data goes from, in terms of age, goes from 20 to 70. So 40 smack bang in the middle. We are interpolating within the data range. A couple of you put that it was close to the 45. That's not the right answer. It's within the data range or interpolation that they are looking for. That's the two keywords. If we tried to use 400 here, that's way outside the data range. Bad idea. Okay, won't be reliable because it's within the data range, interpolating, all good.